Hello, this is an Algebra 2 video. It is Chapter 5, Section 8. And I do believe it is the last section of the chapter, which means, lo and behold, you will have a test soon. I'm sure you're excited about that. In the meantime, we are going to be talking about rational zero theorem. You recall in the last video that, well, aside from it being super long, it was that way because there's not really an easy way or a quick way of being able to find zeros when you need them. But in this section, we're hopefully going to be able to help you out with that little bit of a dilemma. So what does the rational zero theorem say? If p of x is a polynomial function with integral coefficients, then every rational zero of p of x equals 0 is of the form p over q, which is a rational number in simplest form where p is a factor of the constant term and q is a factor of the leading coefficient. So that probably sounds really wordy, and you're probably still confused. So I'm going to show you with this example what that means. First of all, it's important that you know that we are looking for rational zeros. This theorem or this formula is not going to help us find complex zeros. It's not going to help us find irrational zeros. So if the 0 is the square root of 5 or if the 0 is 2i, it is not going to help us find those zeros. Excuse me, it's only going to help you find rational zeros. Zeros that are like integers or fractions. It'll help you find those. So how does it do that? You take your polynomial and you're primarily looking at the constant term, which in this case is positive 16, and you're looking at the leading coefficient, which is positive 4. Those are the two numbers that are in play here. And so you'll see here that basically it's p over q, and p, it tells us, is a factor of the constant term. So this is my p, and this is my q. And what I need to do is create a fraction of p over q. So I'm going to get 16 over 4. And what you need is all of the possible factors of 16, including negatives. In other words, you could have a positive 1 and a positive 16, and that would give you 16. Or you could have a negative 1 and a negative 16, that would still give you positive 16. So we have to include positives and negatives. So we're going to have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. These are all the factors of 16. There are no other factors of 16 on the top. And then on the bottom, we're going to do the factors of 4 in a very similar fashion. And the factors of 4 are plus or minus 1, plus or minus 2, excuse me, and plus or minus 4. All right? And you would think that you were done now, but no, you're not. So our final answer is basically for us to come up with all of the possible combinations of this guy. So our final answer, I'm going to try to squeeze it in down here, is to take the ratio or the fraction of all of these. So you have to go 1 over 1. So we're going to go plus or minus 1. 1 over 2, which would be plus or minus 1/2. 1 over 4, which would be plus or minus 1/4. And do the same thing with all the other numbers. So now we're going to go 2 over 1. So that's going to be plus or minus 2. 2 over 2, which is 1, and we already have that in our list. 2 over 4, which is 1/2, and we already have that in our list. And then we go to the 4, and we go 4 over 1, which is 4. And then 4 over 2, which is 2, it's already in our list. 4 over 4, which is 1, already in our list. Then we move on to the 8, so you get plus or minus 8. And then 8 over 2, which is 4, already in our list. 8 over 4, which is 2, already in our list. And then we go to 16. And then 16 over 2, which is 8, already in our list. And 16 over 4, which is 4, already in our list. So basically what this does is it creates for us a list of possible rational zeros. So as you saw last time, we had to make a t-table to come up with where the possible zeros were and then use synthetic division. We're still going to use synthetic division, but now we don't have to go through that whole t-table process. The first thing we should always do is try the numbers that are in this list. So I want you to know that this is not going to tell you what the zeros actually are. It's just going to generate a list of possible rational zeros. So the good news is that if, for example, you wanted to try the number 32, since 32 is not in this list, we're pretty safe to know that 32 is not going to be a 0. If you're going to have a rational 0 for this function, it has to be in this list. So we'll do one more. Remember that we said that the numbers in play are the constant term, which is p, and the coefficient of the leading term, which in this case is 1. It doesn't have a number in front of the x cubed, so we assume that it's a 1. And then we do p over q, which is going to be 12 over 1. And the factors of 12 are 1, 2, 3, 6, and 12. So we have 1 times 12 will equal 12, 2 times 6, and 3 times 4. So I forgot to put my plus or minus 4 in there. All right? And on the bottom, you have just 1. That's always nice when you have a 1 on the bottom, because anything divided by 1 is itself. So really the only possible rational zeros for this guy are the ones that we had already listed. 1, 2, 3, 4, 6, and 12. There's my list. So now we're going to let you do that here, and then we'll go on to our little word problem example here. It says Adam is building a computer desk with a separate compartment for the computer. The compartment for the computer is a rectangular prism and will be 8,019 cubic inches. The compartment will be 24 inches longer than it is wide, and the height will be 18 inches greater than the width. Find the dimensions of the computer compartment. So the first thing you have to know about a rectangular prism is that it's obviously three-dimensional. They're talking about volume here because it's talking about cubic inches. So volume is going to be length times width times height. And we know that that volume for us is going to equal 8,019 cubic inches. So we have to figure out ways to write the dimensions. And they tell us that the compartment will be 24 inches longer than it is wide. So what that means is that the length is going to be the same as the width, but 24 inches longer, so W plus 24. It also tells us that the height is going to be 18 inches greater than the width, so the width plus 18. So now we have expressions for length and we have expression for height, and then we can plug it into the volume, which is length times width times height. So we're going to get W, so volume is going to equal W plus 24, which is the length. The width we're just going to call W, and the height is W plus 18. And all that is supposed to equal 8019. And it wants us to find the dimensions of the computer compartment. So now what we have to do is come up with an equation here. So we're going to go ahead and just multiply W times W. W squared, W times 24 is plus 24W. And then we're going to FOIL that with W plus 18. So that's going to give us first times first is W cubed. Outside times outside is plus 18W squared. Inside times inside is plus 24W squared. And then last times last is 18 times 24W. And I don't even know what 18 times 24 is, but I'm sure my calculator does. 18 times 24 is 432W. And then lastly, I want to bring this 8,019 to the other side. So minus 8019 equals 0. And I'm just going to combine my like terms. So I've got W cubed, 18 and 24 is going to give us 42. W squared. And then plus 432W minus 8019. There is our polynomial equal to 0. Alrighty. So the leading coefficient, it wants us to find the zeros here. And this is where it's going to get crazy. I'm just going to erase some of this stuff so that we can have more space. I'm going to erase this part here. And what we have to now do is find all of the factors. Again, good news is that in our volume equation, the factors that we need, the P is 8019, but Q is 1. So we're just going to divide everything by 1. So just to kind of make our life easier, we're just going to go ahead and write all of the factors of 8019. That is going to be crazy. So I'm going to start by dividing it. So I know that 3 times 2673, 8019 divided by, it's not going to be divided by anything that's even because it's 8019. So divided by 9. Okay, so we're going to do a 9 and 891. And then 8019 divided by 11. So 11 is also a factor, and then 729. I'm trying to leave space here so I can fill in my gaps. 2733. 27 gives you 297. Trying to write them in order, but I'm not sure if that's going to work out. Divided by 33 is 243. And I think an 81 might work. 81 and 99 are the last ones. So somewhere in here there's a plus or minus 81 and plus or minus 99. So basically what this is a hard number, I'm not going to lie, that was a pretty crazy doozy there. That's a really large number. But basically what I've done is I've found all the factors of 8019. 1 times 2673, 3 times 891, 9 times 729, 11 times 297, 27 times 243, 33 times, I lost that little guy. And then actually it was 1 times 8019. So anyway, 81 times 99 are the last ones that are going to give you 8019. So now that we have all those little guys, we can actually go to our calculator and we're going to do synthetic division. So I am now going to erase this top part. And see, last time when we wanted to find a possible 0, we had to just kind of guess. But now we don't have to, I mean, we are still going to sort of guess, but we don't have to completely guess. 1, 42, 432, and negative 8019. Okay, now we don't have to completely guess because we have a list and we know that any of these zeros are going to be in this list. So I only have to find one, because if I find one, then this will become a quadratic and I can plug the rest of them into the quadratic formula. So right now I just need to find 1 0 and it's got to be in this list. So I'm going to go ahead and plug this equation into the calculator. X cubed plus 42w squared plus 432w. So we're going to go ahead and graph that little guy. And then I'm just going to pick numbers. Now remember, we're looking for a 0 remainder. So what I'm going to do is I'm going to use the second trace feature of the calculator. And I'm going to just try a number here. And in the interest of time, I'm going to go ahead and try a number that works, which is 9. When I plug in 9 to the calculator, it gives me a y value of 0, which means that 9 is going to have a 0 remainder. So I'm going to try the 9 because it's in this list right over here. And so I'm going to go 9 and 42 plus 9 is going to be 51. And 51 times 9 is 459. And 459 plus 432 is 891. And 891 times 9 is 8019, which gives us, yay, a 0 remainder. So now we know that one of the dimensions is 9. That's the width. 9. And so, let's see here. Now we can find the others by the quadratic formula. So now I'm going to say that this is my A, B, and C. So W equals negative B plus or minus radical B squared. 51 squared is 2601 minus 4 times A times C all over 2A. So 4 times 891. So 2601 minus 3564 is negative. So basically what this tells me is that this is going to be imaginary. And imaginary doesn't really help us with our problem because it's a real life application of width. So we have two other options, but those options are going to be imaginary. So what we know is that we have to go with the option of 9, which we already know works. So that means that W equals 9. And then we have length, and we have height, and I think the length was 9 plus 24, which would be 33. And then we had, the other one I'm trying to remember was, I think 9 plus 18. I think I already erased that portion that we had just started with. But yes, so basically it was W plus 24, which was the 33, and then W plus 18, so 9 plus 18, which is 27. So your dimensions are going to be 9 by 33 by 27, and so now you can try this little guy. It's very similar. And then we will go on to the last example, which is basically to find all the zeros. We're going to do the exact same thing all over again, only this time it's okay to have imaginary numbers at the end. So we're going to begin, as previously, with P and Q. So this time we're going to get negative 36 over 5. Factors of 36, 1, 2 times 18, 3 times 12, 4 times 9. And I think that that's going to be it. So we're going to get, what did I say here? 4 times 3 times 12, and 2 times 18, and 1 times 36. All over the factors of 5, which are 1 and 5, because 5 is a prime number, so it only has factors of 1 in itself. But now we have to combine those into a fraction. So we're going to go 1 over 1 is plus or minus 1. 1 over 5 is plus or minus 1/5. Then we go 2 over 1, which is plus or minus 2. 2 over 5 is plus or minus 2/5. Then we're going to go 3 over 1, so plus or minus 3. Plus or minus 3/5, plus or minus 4, plus or minus 4/5, plus or minus 9, plus or minus 9/5. This is so much fun. Plus or minus 12, plus or minus 12/5, and then plus or minus 18, plus or minus 18/5. Plus or minus 36, and lastly plus or minus 36/5. Awesome. Those are all of our possibles. And yes, you do have to list them all. I know it's annoying, but too bad. 5x to the 4th, negative 8x cubed, 41x squared, 43219, negative 72, and negative 36. All right, so now what we want to do is pick one of the numbers from our list. As long as it's in this list, it's okay. And sometimes you get lucky and you pick the right one right away. Sometimes you don't. But if it doesn't work the first time, just pick a different number. So I'm going to go ahead and pick, I don't know, I'm going to pick 2. I don't know if it's going to work, but we're going to hope. Okay, so here we go. 5 times 2 is 10. 10 minus 8 is 2, that's going to be 4, that's going to be 45. So 45 is 90. 90 minus 72 is going to be 18. And oh, look at that. I'm a genius. Actually, I just got lucky. So that one worked. So I found the 2 and it worked. I got a 0 remainder, that's great. But this is not a quadratic yet. This is a third degree. And remember, we want it to be a quadratic so that you can plug it into the quadratic formula. So now I'm going to try another number. What should I try here? Let's see. I am going to try maybe 3, negative 3. Let's try negative 3. Nope, negative 3 is not going to work. And by the way, I'm using my calculator to help me right now. I put this equation into the calculator, and I can do the second trace feature on the calculator. I'm looking for a 0, and it's not there, so I'm going to try 9. 9 works. So now I'm going to divide by 9 because 9's in my list here as well. So I tried the 2 and the 9, and 9 times 5 is 45, and that's going to be 47. 9 times 47 is 423. That doesn't seem like it's going to work. 423. How did the 9 work if it's not even plus 45 gets 460? That's not going to work. So, you see how that happens sometimes? That one didn't work. I don't know why I thought it did. So now I'm going to delete those values. I'm not going to delete the whole thing, just those values, and try again with a different number. How about, let's see, negative 1/5. I'm going to try a fraction. So we're going to go 5 times negative 1/5 is going to give you a negative 1. Two minus 1 is 1. 1 times negative 1/5 is negative 1/5. 45 divided by negative 5 is going to be negative 9. And negative 9/5. So it's going to be positive 9/5. But that's not going to work either. So let's try, what is it, 2/5? Let's try negative 2/5. Negative 2. So 1/5 didn't work. And so now we're going to try negative 2/5. I do think that it's a negative 0. So I'm going to try again. So this time, 5 times negative 2/5, 5 times negative 2/5 is going to give us negative 2. That's going to give us 0. 0 times anything is 0. That's going to be 45. And 45 times negative 2/5 is, yay, negative 18. So finally, we get that positive 2 and negative 2/5 both work. So those are 2 of our zeros. So when I list my answer, I will say x equals 2, negative 2/5, and I need 2 more. So now this is a quadratic, and it says 5x squared plus 0x plus 45 equals 0. And I don't even need the quadratic formula to solve this one because I can just subtract the 45 to the other side, and then I can divide by 5. So x squared equals negative 9, and then take the square root of both sides, and x equals plus or minus 3i. And that's going to be my last 2. So it would make sense that I have 4 zeros, 2 here, 1, 3 there. So that's going to be 4 zeros total. And that makes sense because this is a 4th degree polynomial. So now we found all the zeros, and now it's your turn to find all the zeros of these little guys. Now once you have done that, you will have completed your notes for this lesson. And I will see you in class, and thanks for watching.